Hello my dear children, welcome back to my channel Happy Learning. So today you will be learning the very first lesson from your textbook, which is a perimeter. So actually this is my first video for grade 10. So hope you all enjoy this video and understand this lesson better. So under this lesson, we will be covering three main topics, which are arc length, of finding the arc length of sector of the circle, then finding the perimeter of sector of circle, and then at last perimeter of plane figures which contains a sector of the circle. So let's move into the lesson now. So before I start the lesson, I want you to remind now what is a perimeter. Okay, so perimeter of a plane figure is actually the length around this plane figure. Am I right? So as you can see here, I have drawn three plane figures here: circle, a rectangle, and a square. So in order to find the perimeter of the square, you know all four sides are equal. So what do? You add the lengths of all four sides in order to find the perimeter. Am I right? Let's take this as L. So what do? You add this 4 times. Am I right? So similarly for rectangle also we do have 4 sides for here. So in order to find the perimeter, we should add the lengths of all 4 sides. Now, in your previous grade, you might have already learned the circumference of a circle. So, actually, the circumference of a circle gives the perimeter of the circle. Am I right? So, what is the formula we use to find the circumference of a circle? So, let's assume the radius of this circle is r. So, the circumference of the circle is going to be 2 pi r. So this is the most important formula for you to understand this lesson better. So just you have to remember this formula only. So now let's look at the ways to find the arc length and the perimeter of the circle. Okay. So now I have drawn a sector of the circle, which is a semicircle here. Okay, so now I'm going to show you the difference of the perimeter and the arc length. Okay, so what gives you the arc length? Arc length is actually the curved line around this circular lamina. That means this is the arc length now. Okay, so these are two different things actually. The arc length and the perimeter are two different things, terms when you consider this semicircular part. Because the arc length gives only the curved length, whereas the perimeter gives you the length around this of semicircle. So which means you need to add the length of the arc as well as this part. Whereas in this case, this is the diameter. Am I right? So diameter is what? R plus another R. So you should add the radius twice. So can you identify the difference of the arc length and the perimeter in this sector? So now let's look at the ways to find the arc length of the sector of the circle. So now let's look at the formulas to get the arc lengths of different kinds of sectors of the circle. So first I have drawn a semicircle here and I'm marking the radius as r. So I already told you that you need to remember only this formula in order to find the arc length. So remember the arc length of the semicircle is the formula of circumference, which is 2 pi r, should be multiplied by half. That's it. Okay, so what did we do? We wrote the circumference of the circle's formula, and since this is the semicircle, we are multiplying the equation formula by half. That's all. Now let's move on to the next one, which is a quarter circle, and I am considering the radius as r. Here the arc length, which is this curved line only, okay, it is derived by the formula 2 pi r into 1/4, because since this is a quarter circle, we are multiplying the same formula by 1/4. Now you already might be able to guess the formula of this. Okay, so what do you need to do? This is a 3/4 of a circle, so the same formula must be multiplied by 3/4. Okay, and at last, now apart from these three, if they give you any other sector of the circle, remember they might give you the angle here formed at the center. So here I am marking the angle as theta. So theta is actually a algebraic symbol to denote the angle. So how do we find the arc length for this sector? So here also, to the same formula, 2 pi r, the radius is r, you should multiply this by theta over 360 degrees. Why? Angle around the point is going to be 360 degrees. So that's why we are writing it as theta by 360 into 2 pi r. So now here the fact you need to remember is, now we obtain this half also from this only. That means 180 degrees, right? Semicircle contains the angle as 180 degrees. So 180 divided by 360 is going to be half. So that's actually the simplified fraction of this angle. So remember, this is very easy. If you remember this formula, you will be able to find the arc length of the sector of the circle. So in order to give you a clear understanding of what I taught you already, here is a question from your textbook from exercise 1.2. So find the arc length of each of the sectors given below. So here I am going to do this question only, which is the angle at the center is 60 degrees and the radius is going to be 21 centimeters. So first we'll write the formula to find the arc length. So remember, the question is, look carefully that the question is only to find the arc length. So the arc length of this sector is going to be 2 pi r multiplied by, since this is 60 degrees, 60 out of 360 degrees. Now all you have to do is simplify this properly and find the answer. So let's substitute the values of r and the pi first. So 2 into pi 22 by 7 and the radius is 21 centimeters. So you can cut off the numbers to simplify, am I right? So I'm going to cut the zeros first and I can divide 36 by 6. So simplifying by 6 here. 6 times 1 is 6. 6 times 6 is 36. And here I'll be able to cut it off by 7. 7 times 1 is 7 and 7 times 3 is 21. So I'm going to write the remaining numbers. The numbers on top are 2 into 22 into 3 divided by 6. Okay, so this is very easy. 2 times 3 is 6. 3 and 3 can be cancelled. So the remaining is 22 centimeters. So this is an example from your textbook. So the next topic we are going to learn is to find the perimeter of sectors. Now I already told you about the difference of finding the perimeter versus the arc length. So I'm directly going to explain this through two examples. Okay. So in order to find the perimeter of this semicircle, you know it contains two sides. One is the arc length and the other one is this diameter of this semicircle. So first we are going to find this arc length. Okay, so let's find the arc length of this semicircle, which is half into 2 pi r. Okay, so now let's substitute the values of into 2 into 22 by 7 for pi, and for radius the value is 7 centimeters. So you can cancel 2 and 2, 7 and 7. So the arc length is going to be 22 centimeters. Now, is this your answer for the perimeter? No, right? Right. So let's find the perimeter now. Perimeter is actually what? The arc length, which is 22 centimeters, plus this whole length, which is 7 plus 7. Since that's the radius, this is a diameter, so you have to add the 7 twice. So what is the answer? 36 centimeters. So now let's move on to the second example. So let's find the arc length first. So the arc length is 60 by 360 into 2 pi r. So I'm going to substitute the values first. 60 by 360 into 2 into pi is 22 by 7, and the radius is 21 centimeters. So you can cancel the zeros. 6 times 6 is 36. 2 times 3 is 6. Then 3 times 7. 7 and 7 can be cancelled. So the arc length is 22 centimeters. You can check the previous example as well, the one which I did before from your textbook. So this is the same question as before. So now I'm going to find the perimeter of it. So remember, this question is about find the perimeter only. So the perimeter is the arc length and the other two sides. Can you see? So what do you have to do? You should add 22 with the radius, which is 21 plus 21. So let's add all three together. 64 centimeter is the perimeter of this sector of the circle. So that's all, children, for me to explain to you all regarding this lesson. So let's look into few questions from your textbook so you can understand this lesson a lot better. So the question is, a semicircular portion of diameter 7 centimeter has been cut out from a semicircular lamina of radius 7 centimeters and welded in the lamina again as shown in the figure. So now this part of the circle, semicircle, the diameter is going to be 7 for this small semicircle. Am I right? So it has been cut out and repasted them again onto this side of the semicircle. So remember, there are two different sizes of semicircles here. So remember, children, the place where you might get mistakes is to find the radius, differentiates the radius and the diameter only. So look closely. The small semicircle's radius is going to be half of 7. Am I right? Whereas the larger semicircle's radius is going to be 7 centimeters. So please be careful when you do these kind of subs. Now the first question is, find the arc length of the sector of the circle of radius 7 centimeters. That means the larger semicircle's arc length. Okay, so let's write the formula first of into 2 pi r. Why? Since this is a semicircle, we are multiplying the formula by half. Now let's substitute the values. Half into 2 into 22/7, the value of pi, and the radius is going to be 7. So you can cancel 2 and 2, 7 and 7. So the arc length is 22 centimeters. So this is going to be 22 centimeters. Okay, now let's look at the second question. Find the arc length of the sector of the circle of diameter 7 centimeters. So again, we are going to find the arc length of the smaller semicircle, whereas the diameter is 7. So remember, here the formula is going to be the same, half into 2 pi r, half into 2 into 22/7. Now what's the radius? Since the diameter is 7, the radius is going to be half of that. So I'm going to directly write it in this format. You know why? Because you can easily cancel them. So don't try to divide this and write it as 3.5, because it's easy to cancel it in this way. Do you understand? So now let's cancel 2 and 2, then 7 and 7 be cancelled. So 2 times 11 is 22. So the arc length is 11 centimeters. Okay, now the third question. So the arc length of smallest semicircle is going to be 11. So this is also going to be 11, since both the diameter of the semicircles are same. Right, and this only has been pasted onto this side. Am I right? Okay, now the third is find the perimeter of the shaded region. Now, as you can see, this is the shaded region. Now, this is a perimeter. So, look closely how many lengths we should add in order to find the perimeter of this. Now, see, there is this arc length, and then no need to add this. This is not there, right? So the other part is length is going to be this arc length, and again the third one is going to be this arc length. So I'm going to number them 1, 2 and 3. So this is the actual length around this lamina. Am I right? So we are going to add all the lengths around this shape. That's the perimeter. So the perimeter is equals to, let's add 22 and then 11 centimeters, and again another 11 centimeters. So the answer is 44 centimeters. So this is another question from your textbooks, children. The figure illustrates how an equilateral triangle of side length 7 cm is drawn within a sector of a circle of radius the length of a side of the triangle. So remember, you should first mark the given data into this diagram. So since this is an equilateral triangle, so all three sides are going to be same, which is 7 centimeters. And this is a sector of a circle, not this area, children. The sector of the circle is actually this whole thing. So don't get confused with the question. And this is its radius. Do you understand? And from this given data, there is one more important thing you can mark. Okay, so you know the angle, interior angle, magnitude of one interior angle is going to be 60 degrees. Why is that? Because this is an equilateral triangle. So 360 degrees divided by, the interior sum of interior angles of a triangle is 180 degrees, divided by 3 is going to be 60 degrees. So that's why the angle at the center of this sector of this circle is going to be 60 degrees. Now let's look into the questions. Find the arc length of the sector of the circle. So the arc length is actually this AC. Okay, So the arc length is going to be theta by 360 degrees into 2 pi r. Okay, the angle at the center is 60 degrees. So if you didn't find this, you won't be able to find the arc length. So 60 by 360 into 2 into 22 by 7, and the radius is 7 centimeters. So let's cancel this. This is going to be 6. 1 by 6, then 7 and 7 can be cancelled. Then 2 times 3 is 6, so which is 22 by 3. So you can write this as a decimal number as well. So it's going to be 7.3 centimeters. So let's move on to the second question. Find the perimeter of the shaded region. So they are asking you to find the perimeter of this area. So which contains 2 lengths around this shape. Am I right? So the perimeter is adding the arc length, which is 7.3, plus the length of AC, which is the side of this equilateral triangle. So you can mark this length as 7 centimeters. So the equilateral triangle is a very important data where you need to consider and to complete this sum. So the answer is 14.3 centimeters. I'm going to do one more sum for you all children. So this is the last sum. This figure shows 2 sectors of a circle A, B, E, D and C, B, D, F, B. A, B, E, D. So this is actually a sector of a circle. So this is a right angle. So they have already marked it in the diagram. So can you identify this sector? This is actually a quarter circle. See, this ABFD is going to be look like this. So this is a quarter circle. Similarly, the other sector is also going to be a quarter circle, right? Which is CDFD. So now the side length of AB is 10.5 centimeters. So this is actually the radius of this quarter circle. Okay, now the question is find the perimeter of the shaded region using the given data. Now this is your shaded region. How many lengths do you need to add to find the perimeter? Just 2. This one and this one. Now what is this? This is actually the arc length of this quarter circle. And similarly, this is also an arc length of the other quarter circle. Okay, and another important thing is both the sectors are same in its radius. Why? Because this is a square. So now you just have to find the arc length once. Okay, so let's find the arc length of A, B, E, D first. Okay, so for that, since this is a quarter circle, 1/4 into 2 pi r, 1/4 into 2 into 22 by 7 into the radius is going to be 10.5. Now 10.5, I'm going to write it as 21 by 2. Why? 21 divided by 2 is 10.5. So it's easy to cancel the number 7. So 2 times 2 is 4, 7 times 3 is 21, 2 times 11 is 22. So the numbers on top are 11 into 3 by 2, which is 33 divided by 2 centimeters. Now let's find the arc length of this one, which is BCDF. BCDF. Now, do you have to do the working again? No need, because both are similar sized quarter circle sectors. So, you don't have to do it. So, this is going to be the same. So, 33 by 2 centimeters. So, the perimeter is actually what? 33 by 2 multiplied by 2, or else you can add this twice as well. Why? Adding both the arc lengths together will give you the perimeter of this shaded region. So, what is going to be the answer? 2 and 2 can be cancelled. So, 33 centimeters is going to be the answer for the perimeter. So that's all, children. Hope you all did understand. So please subscribe my channel to watch more videos from this grade 10 syllabus. So I'll see you in the next video. Have a nice day. Bye.